where I am in space. Like what y value do I have at each time? Just think about what the derivative, what does the derivative mean? It means the slope of the tangent line, right? What's the slope of the tangent line of that function at each of those? Think about the graph. Okay, so here we have a position function. This tells me exactly where everything is at any given point, right? So let's go ahead and find the velocity function and the acceleration function just so that we have those if we need them. So velocity, remember, is the derivative of the position. So we have 16t minus 4. And the acceleration is the derivative of the velocity, which is just 16. So this actually has a constant acceleration. Okay. So what the question is often going to ask you is find the total, let's see, find the displacement from time equals 0 to time equals 5. And then it's also going to ask you find the total distance from time equals 0 to time equals 5. Okay. So displacement is the easier one. Okay, displacement is easier because all you're saying is where is it at 0 and where is it at 5 and how much are they different, right? It doesn't matter how many times I walk back and forth between me and Casey's desk. How far away are we right now?
5.
Perfect, we're 5, whatever's away. Thank you. So how far away are we right now? It doesn't matter how far I've actually walked all day, right? Okay, so to find displacement, we look at the position function and I say, what was I doing at 0? And what was I doing? Where was I at 5? And how far away are they from each other? So at time equals 0, I was at 0, right? So I was at the origin, at whatever. I was standing at Casey's desk, okay? At time equals 5, where was I? 180?
You put it into the position?
Yep, because position tells us where I am in space, and displacement and distance are both talking about where are you, right? Yeah. So this is where, how fast, and how fast am I, how much is my speed changing, basically. This is where are you, how fast are you going, and how much is your speed changing. Okay, so what is my displacement?
180.
180. I started at 0 and I went a positive 180 away. So now my displacement is 180. But what we have to figure out is, did I move back and forth a bunch of times in between 0 and 5? Okay, so that would be distance. Distance says, hey, you might have been walking back and forth a bunch. So let's figure out what that is. So remember, if I'm walking, here's my number line. If I'm walking left and I want to walk right, I have to stop, right?
But we have a constant acceleration of 16, so we don't. Right?
But you put it into the velocity, right?
Yeah. Yes, so I'm trying to figure out when did I stop.
So you put V of t.
Mm-hmm.
Define it.
Yes, V of t equals 0. So when I wanted to, like, if I'm moving left and then I want to see when did I turn around and move right, I have to figure out when my velocity was 0. Yeah? You got it?
Yeah.
Okay, so 0 equals 16t minus 4. So I add 4 and divide by 16. So I get t equals 1/4.
Yeah.
Okay, so what I just found out is that at time 1/4, I stopped and I turned around.
Absolutely.
I know, right?
Why would you do that?
I don't know. I forget a lot of things at home.
I see.
Usually I remember before I'm out of the driveway. Actually, and I'm usually pretty good. But one time last year when we were blowing up the pumpkin, it was like the day we were blowing up the pumpkin, and I forgot the pumpkin of all things. Like, you can't just not blow up a pumpkin when I've told everyone we're blowing up a pumpkin.
So we got a $500 car and blew the car. I think it's some sort of replacement.
I wonder, how many rubber bands would it take to crush a car?
You need some big rubber bands.
I'd say at least 3.
Okay, so
We've given a good joke before.
Go on.
we can write it on a number line, but I know the number line sometimes messes with people's brains. So let's look at it this way. At time equals 0 to time equals 1/4, I was doing What?
What part of the car are we crushing?
I mean, probably right in the middle.
You wanna go in the middle?
I don't know. I mean, that'd probably be the easiest one to
But
crush.
no, well, it's not. It's pretty hard to like lift a car up and then go in the middle because you have to do something.
Well, no, you just put it up on stand.
Well, yeah, but how are you gonna get the rubber bands under the stands? So I think we have to go to the front or the back.
Right? See, I drive an SUV, so I wasn't even really thinking about that.
No, but you still can't go through.
It would be an interesting experiment to see if we could crush, like, how much faster an SUV would crush or slower they would crush than a regular car. See if, like, one, you guys are safer in your cars or I'm safer in mine.
And you just do like
Why do you think you're
Okay, so we know from time equals 0 to time equals 1/4, I was going one way. I was either going left or right, right? And then I stopped, I turned around, and I went the other way, right? So let's figure out, was I going left or right here?
Let's just put it in.
So I plug in a number that's in between those two into my velocity function to find out if it was positive or negative. That tells me whether I was going left or right. So let's plug in like 1/8. Okay?
When we're done with this, can you just,
Yes.
if we have time?
16 over 8 minus 4, which is 2 minus 4. So this is negative, right?
Oh, whoa.
At time equals 1/8, I was going, my velocity was negative, which means I was going left. Right? I was traveling left from here to there.
And now you have to find a minimum, right?
I know. But the number line makes people crazy, so I'm trying a different way. But it's okay. You know what I mean. Okay, and then I was traveling left, and then from here to here, let's see if I put any number bigger than 1/4, like 1,
Oh, you know it.
into my velocity.
0.
I go back to my velocity, I put in 1, I get 16 minus 4, which is positive, right? So that means I was going right. So I know it's going to make you crazy that I just did a down arrow for both of them. I was going from here to here, I was moving left, and from here to here, I was moving right, okay? How far did I go from here to here? That's the question. We look at our position. What was our position? Here's where we can do the number line to help you see. At time equals 0, where was I? I was at 0, right? And then time equals 1/4. Where was I? -2. Okay. And then time equals 5. Where was I? We figured that out already. 180.
Wait, I thought at 1/4 we were 0. 1/8 we were at negative.
No, 1/4 velocity was 0, but position. We're looking at position.
Oh, yeah.
Yeah. So it's going to be 1 over 16, 8 over 16 minus 4 over 4. Is that right? 8 over 16 minus 1, which is 1/2 minus 1. So shouldn't we be at negative 1/2? I feel like we should be at negative 1/2.
Because -2 was the 1/8. That's 2 minus.
Right, that was the velocity.
You pulled the 4 out, so it was.
Okay,
It should be positive 1/2. Because you pulled the 4 out, so you have 4t minus 1, and then you add the 1 over, so it's 1/2.
if I put 1/4 in here, let me find a spot where I can write this. I have 8 times 1/4 squared minus 4 times 1/4. That's 8 over 16 minus 1,
Oh,
which is 1/2 minus 1, which is negative 1/2. Okay. So these are where I am at each point, right? I'm at 0, then I'm at negative 1/2, then I'm at 180. Okay. So here I'm at 0, here I'm at negative 1/2. How far did I go? Negative 1/2, right?
Yeah.
But we're just saying, how far is that? We don't have to worry about the negative because we're not talking about direction. So we just went 1/2. From 0 to negative 1/2 is 1/2. Now I'm at negative 1/2 and I go to 180. How far did I go? 180 and a half, right? And then I add those two together. So I went a total of 181. Does that make sense? Okay, and really quick, Casey, to answer your question, if I said, what is my speed at time equals, okay, what is my speed at time equals 1/8? Okay, so I say, what is my speed? Well, I put 1/8 into my velocity function, and I find that my velocity at 1/8 is -2. So what is my speed?
Oh, okay, so you just put it into the velocity and then to the positive.
So speed,
So if the velocity is positive, though, the speed would still be positive.
exactly, yep, it's the same, it's just absolute valued.
But you're putting, into the